Morning, or I suppose afternoon, or depending on where you are to you all. I'm going to quickly put my as well, so you at least see who's talking to you today. So, as I said, my name is Paddington. I have been teaching computer science now for, I have to work this out, 18 years now. Back when it was in the UK, it was still ICT, and I've made the transition to computer science, and I've been teaching both in the UK and internationally now for 17, 18 years. I've taught in Oman and Singapore and Abu Dhabi, and I'm currently at a school in the UK. Timings wise, obviously we've got 3 hours for this session. We're expecting a few more participants than we currently have in the meeting. So I think with Nash's permission, we'll maybe give it a few minutes before we get going. I suppose now is an ideal time if you're already on the call, if you have any initial questions. I mean, if there's anything you're not sure about, whether it's the logistics of the call or anything like that at all, now's the time to ask. I can hear myself saying this a dozen times a day from back in COVID, but I've got my screen shared. So if somebody could just give me a yes or a thumbs up or something that would confirm that you can see my screen. It's the one that just simply says it's the Pearson front sheet, the Pearson welcome slide, sorry. And I'll say, I've been teaching computer science for an awfully long time. First time I've done one of these. So again, I'm going to sort of manage it as best I can. I'm going to have a quick look in the chats here. Somebody's got a chat here. That's just putting stuff in there. That's fine. Okay. But yeah, if somebody could just give me a thumbs up in the chat to let me know that you can see my screen, that's quite important at this point. That would be great. Or a thumbs down if you can't. I'm assuming you can. Nash, you've confirmed that you can see my screen, haven't you? I think so. I think we should be okay.
Yeah, I can see your screen.
Fine. Okay, everyone else is just really shy. That's absolutely fine. Nash, how many are we expecting today? Can you tell me?
Actually, the delegates here are 6, but let me double check if we're gonna have more people coming in.
And it was a higher number than that, but obviously I don't want to leave the 6 people who've got here on time waiting. So
Actually, just a heads up. Earlier we're encountering some issues in Zoom, so
okay, yes, yeah, I had one of those myself this morning. So we've got 6 delegates. So if you're on the chat, if you're obviously on the call at the moment, you're only one of the delegates. Could you just do me a favor and in the chat, just introduce yourself, give us your name, maybe your location, tell us whether you're new to computer science, whether you're new to the specification, or neither. Just so I'd like to know my audience. So your name, your current location. If you want to put your school on there as well, that's great. If not, that's entirely up to you. And then your experience with this specification and your experience with computer science in general. Welcome, Muslim. Is it, again, I will do my best with every pronunciation, but I believe is it Massum? So welcome, Massum. So I'm being told there's a few issues for a few people with Zoom this morning. So we'll maybe give it a few more minutes and then we'll get going because there's a lot to get through, and I want to make sure we get to the point where you're having a go at marking some of the content, so you get a good understanding of what we're trying to do here. So, Massim, if you've been teaching this for 3 or 4 years now, what are you hoping to get out of today's session? Rania, welcome. Egypt, living Dubai, excellent. Okay. Okay, the Cambridge GCSE. Yeah, it's interesting. In in two of the schools I taught in as head of department, I've changed from Cambridge to Edexcel on both occasions. Um, I'm going to try and pronounce it, Silverius. I hope I've said that right. Kenya, beautiful. Okay. Teaching the Pearson specs. Have you been teaching it since January because when the school year starts? I don't think that's when the school year starts in Kenya. Silverius, or did you pick it up from somebody else, or is that when you joined the school? Welcome to you as well. Welcome to you both. Nash, I think we're up to what, eight delegates now, so and we're 10 minutes in. We'll get a couple more minutes. There seems to be people kind of crawling and creeping in, and we're all getting to know each other anyway. Eric, welcome. Based in Kenya. Okay, new with the concept, so new with this one. Okay, so you plan so introduce the subject to year 7 students. Okay, so as in, so you're going to introduce a key stage 3 program of study leading up to the GCSE computer science, or are you going to start the sevens on a key stage 3 program of study and then also have your year 10s, let's say, start on the computer on the GCSE? Is that the plan? I know that the text chat is a very difficult way to answer these quite specific questions, but I find, again, having taught internationally for 12 years, I always find it fascinating one, all the different places that our subject is offered, and two, um, just the range of approaches um, to delivering computer science. If you've just arrived, welcome. And if you haven't introduced yourself, that'd be lovely. If you could, no pressure, you don't have to. I know for some of these sessions, some people it's like, I'm going to sit back, I'm going to be quiet, I'm going to listen, I'm going to do stuff, and then I'm going to be out of here. But if you've got anything else you want to add in the chat, that'd be great. I'm going to speak to Nish. How are we doing? Is anybody still trying to join? Do we know, or should we get going? It's 11 minutes past now, so. Okay, guys, unless I'm not sure how many other people are going to arrive or are going to arrive, but I think let's get going. Okay. Um, as you know, as I'm a teacher, the same as all of you, you are so, and I'm sure you'll find it very strange talking to um, a screen back in COVID, talking to a screen or talking to a quiet room. So as we go through this content, I'm more than happy to field questions to queries, whether it's the how to deliver, um, if there is stuff we're doing that you're not sure about the actual computer science theory behind it, and you want a little bit of help with that. I'm sure between myself and anybody else that wants the chicken will be able to help with that as well. But other than that, we will get going. So, um, here's what we're going to try and do today. Um, so we're going to have a little bit of a look at how this qualification is devised. We're going to have a little bit of a look at the content of the qualification. We're going to have a look at how to plan the course and or individual lessons in a little bit of detail. I'm a big believer that you obviously as a teacher, you know yourself and you know your situation, you know your students best. So we'll give some, and you need to decide that the planning the course and the lessons best, but we'll try and give some help with that as well. Understand how the qualification is assessed and how you can prepare students to be ready for that. Understand the assessment objectives. I think that often gets overlooked. So we'll try and have a little bit of a look at that. We'll have a look at the type of questions that are being asked for this qualification. I'm looking at my chat here. Okay, thank you, Massim. Yeah, correct. I agree. Okay, so have a look at the question types for the two papers, the mark schemes for the qualification, how to use them a little bit. We'll have a little bit of a practice, and then we'll end by looking at some of the support provided by Pearson, which certainly from my point of view was one of the reasons I chose Pearson. I think the pre and post exam stuff is great. So. Okay, to Pearson. Um, Pearson, I'm going to sort of leave this information on the screen for you. Obviously, huge organisation, um, a huge range of qualifications as well. Obviously, we're discussing the GCSE computer science here, the IGCSE computer science here. There's a GCSE version. They obviously got there's the A level. There's the BTEC, which I've just started, the BTEC AAQ, which I've just started here at my school. Yeah, and lots of opportunities with Pearson as well. Um, you know, I'm a teacher by trade, but I'm here doing this because it's interesting and it's good for me as well. But there's lots of things like marking and that kind of thing to get involved with, which is always well worth, especially from a professional development point of view. But there you go, a big organisation. Okay, so let's have a little bit of a look at the overview of this qualification, the IGCSE in computer science. And we're going to have a look at the content first. So the content is split up into these topics. So the first couple of topics are based around problem solving and programming. So students be able to create algorithms, determine correct output. So trace tables, trace algorithms, some standard algorithms that are out there. So they might have to do sort of research. The just how fit for purpose an algorithm is, i.e., does it do what it's supposed to do? Does it meet the needs of the user? And then they should be able to either talk about those algorithms in words, just a description, or flowcharts using the standard symbols, pseudocode using some recognized standardized terminology, and code. Okay. And then for the second part of problem solving, decomposition and abstraction. I'm very aware that I'm speaking to computer science teachers. I'm also aware for some people this may be their first foray into computer science. I know that what happens in some schools is that school says, okay, you're you're pretty good at technology. We need to deliver the computer science. Can you deliver that? So I won't apologize if I occasionally explain some of the terminology in here that is computer science specific. So in simple terms, decomposition is breaking stuff down into smaller parts, so those smaller parts can be saved and then put back together. And abstraction is complexity hiding or removal. So making sure that that when you're looking at something, you're focusing on what's important and ignoring all the stuff that you don't need to worry about. So students need to be able to analyze problems, design problems, as I said, decompose into smaller sub-problems. We do that all the time in real life and in work, and it's just, but we realize that. Abstraction to model real world. So, for example, I always use the, and it's usually whatever country, I mean, the transport map of my locality to show that actually this isn't really what this location looks like, but the transport map is abstracted to that, and then create abstract of real world examples. Okay, that's topic one. Topic two is programming, and I think it's probably fair to say that for many teachers who are new to the subject, this is the bit that they find the most challenging. We're very fortunate nowadays that, and I've been saying this for a few years now, that when it comes to resources, certainly for delivering coding, there is a huge amount of stuff out there. What's great is that computer science teachers globally seem to be really keen to share what they know, and then are really great at putting together digital platforms to show that as well. So there's a whole range of stuff out there that can help you with programming if you're not sure. But they need to build, and this is for that they'll have to do this live. They have to be able to develop code. So write a program. Can they identify or fix errors, debug? Can they trace through a program? Can they evaluate the effectiveness of a program? The main construct of programming, so selection, repetition, and iteration. Well, if anybody needs to know, we'll discuss the difference between repetition and iteration, but it is something that they are different. We're talking about while loops versus for loops. So condition control loops versus count control loops, and then there's precondition loops and post-condition loops. But they need to be aware that those are different things. Data types and data structures. So your primitive data types such as floating integers, data structures such as, and you've got 1D arrays, 2D arrays, how to implement those, how to iterate through them, what a record is and how that differs from an array. They need to be able to accept and respond to input, validate that the input is the correct data type or the correct length or the correct or formatted correctly, and they need to read and write to and from text files. They need to be aware of operators such as Boolean, relational, and arithmetic. So and or and not, and greater than and less than, and your pluses and your minuses and your modular, so your integer division and your remainder division, that kind of thing. And then with the subprograms, so function procedures, they need to be able to define them. They need to be able to, once they're defined, they need to be able to use them properly. They need to be able to pass parameters those functions correctly, functions and procedures correctly. And if it is a function, they need to be able to return from it. I hope we're all okay so far. That's topic 1 and 2, which are the sort of the problem solving and the programming ones. Before I move on to topic 3, everybody okay with that? Anybody need anything clarifying from that content? If you want to pop in the chat. If not, I'm happy to keep going. Nothing in the chat. Okay, we'll keep going. Okay, so we're now on to the theory topics. So which make up the majority of paper 1. So they need to be able to use the base-2 number system binary. They need to be able to represent positive numbers, negative numbers. They need to be able to convert between denary and between binary, a bit of hex thrown in there, hexadecimal, sorry. They need to be able to add together binary numbers of up to 8 bits, I think it is at the moment, and be able to understand overflow. Need to be able to talk about ASCII and Unicode as character sets, images, especially bitmaps, and how the file size is calculated. Again, sound, and again with those kind of topics, the correct terminology is really important. So data storage and compression, so using the correct units, run length encoding as a method of lossless compression, calculating storage requirements for data, and then encryption, what it is, why we have it, and then just a range of relatively straightforward cipher algorithms that can be applied. Then we're on to computers. So they need to know about machines and, and computational modeling. So I often refer to it as IPOS, input, process, output, and then some kind of storage. What multi-agent modeling is, what parallel means. They need to be able to talk about hardware such as the microprocessor, the CPU, cache, RAM, cloud, the relationships between those. They need to be able to talk about logic and logic gate, so and or not. And then in regards to software, they need to know what an OS is, what some of its functions are, utility software, application software, and how all those relate to each other. So, yeah. And then programming languages. So what's a high-level language, what is a low-level language, and then translators, different types of translators, such as an assembler or an interpreter or a compiler. Okay, next one. On the first here, we've got topic 5, communication, the internet. Three bullet points or 3 topic headings here. I think I've seen in the past people have kind of thought this was a shorter unit. It's not. Okay, this is again just because it's got fewer descriptions, it's still don't allocate less time to it. Again, can we talk? They need to talk about topologies, bus and star, layered protocol, so TCP/IP. Media within networks, they need to talk about what makes a network vulnerable, how do you protect a network, the role of cloud in network security. And then again, knowing the difference between the internet and the World Wide Web, knowing IP addressing, how IP addressing and name servers and components go into making the internet what it is, and how the World Wide Web then relates to the internet. And then the last one, and this, which it's funny, and again, I speak from experience, and some other people may have experience on this. This is the one that almost turns computer science from being a science, or not turns it, but it suddenly becomes more of a social science, almost becomes a humanities subject, which I think is sometimes really challenging for us as computer science teachers. At schools in the past, I had my projected grades for my students based on their maths ability, forgetting that actually there are questions that essentially require some quite well, lengthy writing is not the right word, but there might be a 6-8 mark question where they have to write these kind of things about things like the impact that technology has on our health, on our energy use, on our natural resources, ethically, what's going on at the minute with privacy, with inclusion, with professionalism, talking about the IEEE, certainly in the UK. Legal stuff such as the Design, Copyright and Patents Act, and the Data Protection Act, the Computer Misuse Act, and this is the one that I think sets computer science apart from just about any other subject and makes it really, really interesting. Is that we as subject deliverers are having to change what we are teaching every year. So now in topic 6, the big picture for emerging trends, we need to be able to talk about quantum computing, DNA computing, AI, nanotechnology, stuff that certainly, I'm trying to think back, 5-6 years ago wouldn't have really been a particularly big topic, but now they are. like the A-level specification I was delivering previously dropped quantum computing in as a couple of years ago. And I had students who were very good physicists who we were having to kind of work it out together, and that's what happens sometimes. So I think as a subject we are almost unique like that, in that it is such a fast-moving subject, and it is such and the stuff that is fast-moving having such a direct impact on society itself. That being able to keep up with that kind of thing is really important and quite challenging. Um, I've had the running joke with a colleague who teaches French that I could go back 200 years and introduce myself in French using the same words as I could do in modern day France, and it would be exactly the same. But if I went back 200 years with a laptop, then I'd be goodness knows what happened to me. Okay. So those are the six main topics. Does anybody have any questions about those before we move on? Feel free to put it in the chat. I'm trying not to let my well, I suppose personal opinion. I'd be interested if anybody else kind of found that about the subject, that there's always something brand new to learn. In a previous capacity, I taught the IB, the International Baccalaureate, and they have a case study, and every year it was something absolutely brand new. But it's what's happening with the GCSE and with the A levels now. Okay, nobody seems worried about that, so okay, let's move on. Okay, so let's talk about assessment objectives. I think these are a little bit overlooked, but it's helpful to understand them just to see what the balance is in regards to the content you need to be covering. So there are three layers, as it were, of assessment objective: AO1, AO2, and AO3. And the keywords here are the first words in every box: demonstrate, apply, and analyze. So AO1, which is, as you can see, roughly just over a quarter of the qualification, is can students demonstrate knowledge and understanding of the key principles of computer science. So that would be your multiple choice questions, maybe your 2-mark questions. Can they define something? Can they say what can they say what a VPN is, for example? Can they give a definition of something? AO2, which is not far off half of what they need to do, is just taking that a little bit further. So it's maybe your 3 and 4-mark questions where they not only do they know something, can apply that knowledge. So they can talk, for example, about I'm going to come back to VPNs. Not only can they say what a VPN is, they can talk a little bit about how VPNs have changed working patterns, or have removed geographical restrictions for people. And then the last one, AO3, which is the analysis part, and this again is heavier, I would suggest, in paper 2, where there's a lot of programming. But this is, can they then analyze that? So again, let's go back to the VPN example. This would be so the first one is, what is a VPN? How is it affect? What effect has it had on, or what changes has it made to the way people work? And then what effect has that what effect has that businesses and individuals? They can talk about improved work-life balance, that kind of thing. Okay. Okay. There's nothing in the chat, so I'm assuming everybody's okay with assessment objectives. Okay. Okay. And just to show you the breakdown a little bit more. So for people, which is the principles of computer science, the majority of the stuff is on AO1 and AO2. So that kind of defining and explaining. The AO3 in principles of computer science will tend to be a longer mark question, which often, but not always, around actually that topic six. So it'll be a question about, then maybe give a case study and then ask the student to discuss the impact that blockchain technology has had on our as on our use of energy, or on the impact on the environment. And then, for obvious reasons, paper two has a lot more on AO3 because it's a lot more coding and a lot more problem solving. There is the odd sort of it's a mix, isn't it? Paper two, so there's some that you do on the paper, some that they have to code. So there'll be some questions on the paper, which is more focusing on just knowledge demonstration of that topic, and then after that, it's into some code. Okay. So just to have a look at how this assessment is structured. Okay, so here we go. So again, if I know sort of if you're new to this, some of these may not make 100% sense, but anyway. So 100% external examination. So there's no internal project. Fully linear. Again, for those of you who are not sure what that means, essentially the content is delivered over 5 terms, the 2 years, and then they sit all both their exams at the end of 2 years. 9-to-1 grading scale, which came in back in the I want to say 6-7 years ago, maybe. I think we're probably used to it now. I think some people probably pine for the A star to however low it went. But I think we're now kind of making sense of the 9-to-1. Certainly, I remember when that first came out, having to prepare a relatively or an information for our parents to explain how 9-to-1 mapped, or A star to E mapped across to 9-to-1. And as I said, there's 2 papers, each with a weighting of 50%. There's the written exam, paper 1, Principles of Computer Science, which is topics 3, 4, 5, and 6 predominantly. And then you've got the practical exam, which focuses on the problem solving and the programming. It's always really interesting to see the difference in performance schools between those 2 papers. Yeah, I'd be interested to know if anybody who's been doing this for maybe a couple of years has found that their students find one of those more challenging than the other. I think certainly we find in the UK that with perhaps not as much time being given to students at Key Stage 3 for computer science, and they're perhaps not as much time to do coding and computational thinking, that getting them up to the standard needed for that paper 2 can often be quite a challenge. Extra more chat. Kind of. What's that? That's a great question. I know is my understanding, because it's linear. They sit their paper at the end of the 2 years, and then they're out of their GCSEs. I know that obviously, what you're thinking about, and rightly so, is modular qualifications at post 16, where, for example, students, if they're doing an A level that's got 4 papers, they can sit 2 papers at the end of year 12, and then at the end of year 13. But if they don't do particularly well at the end of year 12, then there's often a January and maybe even a June resit. I know that's the case for some of the BTEC qualifications that have an external qualification, that if they don't do particularly well at the end of year 12, they can retake them, at least once in year 13. But the nature of the assessment is that if they can retake, if they want another go at the paper, they would have to wait probably for the next exam window and sit the whole thing. I will check, and I don't know if Nash is listening, but whether she check as well. But I'm pretty sure they can't, Maria. I'm pretty sure, but again, I'm gonna let's part of that, and I'll try and find out. Okay. What's next? Right. Oh, sorry, my double click. First paper is Principles of Computer Science. So it's an external examination, 2 hour non-tiered practical examination. Uh, so there is a specific time that they sit this exam. Again, I didn't see last year was 23rd of May, and it was an afternoon one, so probably started at 1:30. 80 marks to go for in 2 hours, which I think is fine. I tend to put on my assessments when I'm doing my assessments with my students in lessons. I tend to work on the principle of roughly a mark a minute. So 120 minutes for 80 marks is okay. On the whole, students seem to be okay with that amount of time. Traditional written exam paper. Sit down, open the booklet, answer the questions where it goes. All questions require a written response. All questions are mandatory, so there's absolutely nothing. Every question has to be answered, or every question is expected to be answered. And there's a whole range of question types. So there's multiple choice, short open response, extended open response. So again, multiple choice will be pick the right one. Obviously, short open response maybe 2 marks, open response 3 to 4, extended open response. That's when they're answering their longer questions. I'm trying to keep an eye on the chat as we go. Oh no, you're welcome, Ronnie. Thank you. Okay, next one. So paper 2. So again, 3 hour non-tiered practical examination. For this, just because of the logistics of running this kind of exam, there is a 3 hour window, 3 day window provided. I know that for many schools, finding that space with the right number of computers, with either the right distancing or with some kind of separator between the rooms, can be a little bit of a challenge. So to kind of give the exams officers, who's asking this one? Sorry, is that Massive? Okay, Massive, that's a great question. I'm going to speak for Pearson. Yeah, all my contract for Pearson, I don't. That's not a question for me to answer as a Pearson contractor or employer. It's an interesting question, and I think as computer science teachers, we need to be very much be champions of our own subject. I think it's not a difficult argument to make to say that it is as important as it ever has been. So we need to be the champions of our subject. I know that's perhaps not the answer you were looking for, or maybe not even answering the question. But I can only speak for myself as a computer science teacher and say that all I can do is champion my subject in my school as early as possible. I have a lot of conversations with the computer science teachers in the lower school on how to increase the interest there. Yeah, it's an interesting one. Sorry, I got distracted by a very good question. So to come back to this, sorry. Yeah, so 3 day window so that you know there's a little bit of flexibility in making sure that the rooms are available and that kind of, again 80 mark. This one's 3 hours for 80 marks. From experience, your very able coders will fly. Will fly through. Yeah, they'll have the questions answered very quickly. Others will need the whole 3 hours. That's fine. And again, you've got multiple choice questions, short open response, and then excuse me, to answer the last one, the task-based questions. So, as you can see on the description here, they must have a computer workstation with appropriate programming language code, editing software and tools, including a code interpreter compiler. So what will happen is at some point you're going to have to get this codes folder onto the computers they're using. They need to not have internet access, those computers. So you'll probably need to have a locally hosted IDE. We use Dolly just because it's very, very nice, light and simple. Because at some point they're going to have to access that codes folder, open up a Python or sorry, I mean I say Python because it's what I use. Open up the file for the coding language of their choice and answer the questions, and then it'll either ask them to put something in the question paper, or they'll have to save the result of their coding as another Python file, and that'll get submitted. Okay. Okay. So you all have, I hope, in front of you the delegates pack. So I'm running two computers here, so I can see what you're doing as well. So there's the Word document that's called Getting Ready to Teach International Computer Science, International GCSE Computer Science. So we've got a few activity or 3 activities for you to have a go at to start with. So this first one, and I'm hoping you have the specification in front of you as well, because I know it's in the booklet. So you've got the specification that's in your delegate pack, and you have this Word document that's in your pack that's called, as I said, Getting Ready to Teach International GCSE Computer Science. So there's if you scroll to the second page, I think there are 7. Yeah, there's 7 spec learning descriptors that have a bullet point that go with them. So if I say, let's say 10 minutes. So by my watch, it is currently 9:44. So at 9:55, so let's say 11 minutes, because it'll be 10 by the time I finish talking. We'll come back and we'll make sure that you found the right specification bullet points for those learning descriptors. Just let me know if you haven't currently got the pack, or you haven't got the spec, and we'll try and help out. But I'm hoping that I know in the chat that Nash put the link to the event material. So if you haven't got the event materials yet, they're in at the start of the chat. So it's what I said. It's as I suspected, 9:45 now. So at 9:55, we'll come back together, and we'll just check that you've been able to link those specification bullet points with the specification descriptions with the bullet points, the bullet point numbers from the specification. Is that okay? That makes sense for everybody? I don't. Okay. I'm going to make sure I explain this right. So these are examples of questions. Okay. So convert 4 gigabytes to kilobytes, and so you're going to go and find out that it's about the storage measurements. Okay, the IEC storage measurements, and you'll say, okay, well that's bullet point 3.3.1, and some of them come with notes. Okay, I'm going to be quiet for 10 minutes. And at the end of 10 minutes, we'll go through and just make sure that we've got the correct bullet points for that. I'm going to quickly talk whilst you're doing the last little bit of writing. Um, I mentioned earlier about how um, the relevance of our subject, and I think perhaps Massa, maybe this goes a little way to sort of how we can talk about our subject to parents and students. So, AWS, Amazon Web Services, which is one of those huge companies that kind of underpin, a lot of infrastructure on the World Wide Web, is currently reporting outages. They've got some kind of technical problem going on, and I'm just looking at who's impacted by this. So, Fortnite, Canva, there's some banks, Live 360, MyFitnessPal, Snapchat, but interestingly, Zoom. So I think Nash was saying that there have been some problems with people getting onto the call today because there are issues with Zoom, and it's global. It's a global issue, but it also allows us to then talk about the impact of us all using software as a service or infrastructure as a service. I think the great thing about subject is that you can walk into a lesson on almost any day, and there is a news item relevant to our subject that's happened in the last 24 hours. Massimo, I hope that kind of that makes sense. I hope that kind of again perhaps goes at least a little bit towards answering the question. Okay, I hope you're all almost finished with that one. Um, Again, I'm not hearing any. If I'm not hearing any, so I'm going on the basis that no news is good news. So nobody's saying that they can't access the content. Nobody's saying that they're having any problems with that. Let's go on to activity 2, also on the same sheet. Oh, so activity 2 is these are descriptors from the specification. So your job is to find that in the specification. I'm sure some of you will be able to make very good use of the find tool in your PDF viewer or whatever. But if you can find the specification point that it goes with, and then the other suggestion is the teaching order. Okay, so as it says, the number of let me get rid of this a sec, sorry. I said the numbering of the bullet points might not represent the most suitable teaching order. So from all the things you've got there on that, so on this on activity 2, we're just asking you to find the specification bullet point, and then if you were going to have to teach those 10 specification items, in what order would you teach them? Okay, you might, for example, decide that the top one will need to certainly come after understanding the input, process, and output model. and it would probably need to come after understanding the function of hardware, and probably also need to come after understanding the function of different types of memory. Would you then introduce the stored program concept with its units, its registers, its buses, etc.? So you've got 10 items. Find the specification bullet point for each item, and once you've got them, order them 1 to 10 in the order that you would deliver this content over the space of, this would probably be a few weeks, wouldn't it, to try and get all this done with the students. Okay, again, just remembering the bullet point specification is not necessarily representing the most suitable teaching order. So I'm going to ask again. Please let me know if you haven't got access to a specification. If you haven't got access to the Getting Ready to Teach International GCSE Computer Science book with these bullet points on. Other than that, I think this is a slightly lengthier one, I would suggest. So the time is now, I make it 9:57. So let's say 13 minutes. So let's aim for, certainly, I know I'm talking to people in all different time zones, but it's 3 minutes to the hour now. Let's again come back together at 10 minutes past the hour. I want to have a look at these ones. Does anybody have any questions about that? I'm going to ask the question I ask my students at the start of every piece of work they do. Is anybody not sure what I've asked? Anybody not sure what they're doing? Nobody's not sure. And I've still got, okay. It's very quiet out there. Okay. So 10 minutes past the hour. Oh, I've got a chat here. So, right. So again, I'm open suggestions. Randy, would you rather we went through the answer for activity 1 first, and then we'll go on to activity 2? Would that be better for you? You get a chance to speak for everybody here, Randy. If you'd rather we quickly blitz through the answers for activity 1 and then go on to activity 2, just let me know. I'm happy to do that. Perfect. I agree, Randy. Let's do that. Okay. So, Randy, I'm just glad there's somebody listening. That's my main at the moment. Okay. So for activity 1, okay. So number 1 is answered for you. Let me use that. So let's go back to. So we're answers for activity 1, as rightly suggested by Rania. Okay. So next one, discuss the statement artificial intelligence is more than just robots. Is specification bullet point 6.1.4. Okay. And that's the notes on that is about natural language processing, machine learning, and speech recognition. I mean, and that is such a, yeah, the artificial intelligence is such a buzzing at the moment. You may have the same, but I've as somebody who's had to sort of study and learn about artificial intelligence, machine learning, recurring neural networks, deep learning, all these all this stuff. It can be quite painful to sit and listen to colleagues kind of butcher what it's actually about. But anyway, different thing again. Okay, question. Number 3. To give 2 advantages of IPv6 over IPv4 is bullet point 5.3.3, and the notes that go with that just talk about IPv6 providing more addresses, more public unique addresses on the internet, and then actually IPv6 works better with mobile devices. Anybody want to disagree? I'm open to discussion. I hope you agree with those ones. I hope you're getting these ones correct. Point number 4 is 3.3.3, so run length encoding with lossless compression. And again, the issue with explain the effect of applying run length encoding on this pattern. So it would be IJK. Yeah, there's not a lot of repetition there, is there? Again, I'm not sure how much you know about run length encoding, but what we're looking for is as many long sequences of the same thing as possible. What that would be a problem here. So, yeah, it wouldn't compress at all. Yeah, so the notes, the encoded output would be longer than this input because every single letter would become a letter digit. So, for example, we've got AA, that would become 2A, BBB would become 3B, but then C, D, E, and F would become so 1C or C1, depending on how you're encoding it, D1, E1, F1, which would double the amount of space needed to store that data. Okay, so that's a nice uh, question on them understanding the limitations of run length encoding. Number 5, so the question is the stored program concept assumes that the bit pattern stored in memory can represent only two items. Name these two items. So that's just about what is held in memory or RAM, data and instructions. It's as simple as that. And that's spec bullet point 4.2.3. Yeah, minimum number of passes the bubble sort must make through the data and why. Again, some students will be tricked into putting 0 for that, I would assume, because it's already sorted. But you need at least one pass because if it's sorted, the pass has no swaps, then it's sorted, therefore it's okay. But it's a bubble sort must have at least one pass, and that's bullet point 1.1.8. Number 7, compare the use of variables and constants in coded programming is bullet point 2.3.4, and that's just them acknowledging that they know that a constant, once the value is defined, shouldn't change, but with a variable, it's designed to change. Anybody have any questions about any of those? Is that okay? Randy, you're the only one talking to me. Randy, is that okay? Are you happy with that? And we move on to the next one. Great. Okay, so let's move on to activity 2 then. Okay, activity 2. So this one I've explained already, but I'll do it again. So let's jump to activity 3. I was wondering what that was for a second then. There we go. So again, these are, I said 10 specification points, each that comes with a specification number, as you were finding before. But for this one, if you were delivering these 10 specification points over a series of lessons, what do you think is the best order to deliver these in? What we're looking for is obviously is scaffolding. You know, I can't do this unless I do this, and I can't. Yeah. So, time frame wise, and I'm going to speak to Rania because she's the one speaking back to me. Rania, what do you think? If we go for I've got it 4 minutes past the hour. Let's get back together at 15 minutes past the hour, which is 11 minutes. We'll get back together at 11 minutes. If you need more time, you can all just let me know. Is everyone okay with that? Who's going to speak to me? Excellent. Thank you, Rania. Okay. 15 minutes past the hour. I'll speak to you all then. Okay, guys, I'm back. We're back. I'm very aware of time. It's now already 10:15. So let's have a quick bits through these answers. We've still got to talk about, goodness me, a bit of planning stuff, command words, before we get onto mark schemes and stuff. So, um, we're trying to do this a bit more democratically. So, for the first one, understand the concepts of a stored program and the role of components, etc., etc. That is spec bullet point 4.2.3. Okay. Pop in the chat where you put what order number you put that in, please. Anybody would say what order they put that to be taught in? Anybody put it 1, 2, 3, 4, 5, 6, 7, anywhere between 1 and 10. I'm going to start to think nobody did the homework. Okay, excellent. So Rani has gone 10, 7, 8, 5, 2, 3, 6, 9, 1. Okay. That's interesting. I think what's really interesting, Rani, is what you've done is I think this is kind of a content of two halves. And I think you've rightly started with I think it's a really good idea to start with just the last one, which is understand the input process output model. And then but after that you've then started to focus on binary representation, and you've done all that stuff first, and then gone on to the hardware. Is that right? Would I be right in saying that? Yeah, I think a lot of people would do it that way. I mean, I have some suggested answers. Um, I think it depends on whether you feel you want to do the hardware first or the data. I think the way you've suggested it is the data and the hardware is probably the way about half the people would go. I I've done it both ways, and actually, interestingly, it doesn't really make any difference. Sometimes I've gone hardware first, sometimes I've gone data first. But yeah, I can see what you've done is you've taken all the data ones and put them together, which is great, and then done all the hardware ones and put them together, which is also makes perfect sense. Did anybody else do it any differently? It's just me and you again, Rania. Um, yeah, in lieu of anybody else actually saying what they've done, I mean, I'll give you the oh, I think you've probably already got the answers that are on the sheet. So you've got from top to bottom, the spec points are 4.2.3, 4.3.2, 4.2.1, 3.2.1, 3.1.1, 3.1.3, 4.3.1, 4.2.2, 3.1.2. After that, I mean, it's up to you. I think on here it's gone. First of all, is understand the input process output model. Then it was the function of hardware. Then it was the function of memory. Then it was the stored program concept and the CPU. Then it went into binary, and it did understand binary, how numbers are represented, conversion, and then truth tables followed by logic statements followed by encoding. But I agree, Rani, that actually depending upon what you're used to doing and how you know your students, taking them doing the data stuff first would be a perfectly reasonable way of doing it. Anybody else have any? Oh, we've just had an increase in participants, which I'm assuming means that AWS has started to sort out their services. If you have just arrived, I'm assuming you've been having a problem getting into Zoom. Forty would join up now. Okay. you've just arrived, just let me know. Have you go in the chat, please? Quickly introduce yourself and just confirm that it's been a problem with Zoom that you had this morning. Says so very. You've gone very much. You've gone the that it suggested. Yeah, again, going with the hardware and then going into binary is absolutely fine. So if you're a recently arrived participant, I'm assuming you're one of the people that had problems with getting into Zoom this morning because of the AWS outage. Can you just say hello in the chat, please, and just quickly introduce yourself? And then I'll reintroduce myself, and then we'll see if we can work out how to get you caught up. If you have just arrived as well, you should be able to scroll to the top of the chat, and there's the link to the content. Unless these 5 new people that have just joined are just ghosts. Okay, fine. Adam, was it a problem with Zoom? Were you getting the outage message? Yeah, okay. As I'm talking on this laptop, on my other laptop, I've got the information up about AWS's yeah, okay, same, correct. Yeah. Yeah, I literally, as I'm talking to you here, I've got the information here about on the BBC website about the AWS outage, and there's a huge number of websites that are out at the moment. They're clearly just started to get it back up and running. Adam and Kurat, just a couple of things. Let us know where you are. Don't need to let us know the school, but just where you are internationally. And if you scroll to the top of the chat, there's the link for the content for the materials for this for this thing. Adam in the UK. Oh, no, see the link. Let me see if I can grab it again. Hold on one sec. Let me know if the link works for you. Adam, you're in the UK. Okay. Okay, perfect. Whereabouts are you internationally? Adam's in the UK. I think the 2 of us in the UK so far. I'm up in. I usually teach. I teach down in Cheltenham, but today I'm up in Newcastle. Okay, Pakistan. Is that where you teach at the minute as well, correct? Awesome. Okay. Okay. So for those, we're just another person arrived. Okay. So for those of you who just arrived, I'm going to apologise on behalf of AWS and Zoom. I know that it's been probably quite a stressful morning trying to get it to work. As I said, alone. If anybody's got a teenage son, they can probably tell us that confirm that Fortnite is out, as is the PlayStation Network. And anybody that's got a son or daughter can probably confirm that Snapchat's out. My wife is currently trying to work out where my daughter is because Live 360 is not working. That sounded terrible. We know where my daughter is. It's just that they get used to knowing where they are all the time. But there's a lot of stuff out at the moment. Right, so it's a tricky one. So because really it's my only option, I'm going to keep going with the content so far. For those of you who've just arrived, just to let you know what we've covered so far, okay? You can see I'm having to think on my feet here, people. If you have been here since the start, I apologize. I'm going to have a quick 5 or 10 minute blitz through what we've done so far for the people who have just arrived. but I'm going to rather than talk through it all, I'm going to basically show you what we've done, and then if you do have any questions about it, you can ask them and we can try and answer them. Okay, but I think just it's been such a mess this morning with AWS's issues that I need to at least give the people who've been trying all morning at least the chance to know what we've been doing. So here's where we could, the differentiation experience teacher. If you have been on the call since the start, could you please have a look at activity 3, which is that one. Okay, so activity 3 is also on the getting ready to teach international GCSE computer science document, which is in the link which I've shared and which I think you all have. 10 minutes, please, for activity 3, which is having with the questions that are given. What paper do you think they're going to appear in, paper 1 or paper 2, and what's the spec point? Okay, so there's I think there's how many of them? Let's have a quick look. 1, 2, 3, 4, 5, 6, 7. There's 8 of those. So it's now 24 minutes past the hour. Let's say at 35 minutes past the hour, we'll have a look at the answers to those. Then for the people who've just arrived, which is about half a dozen people, I'm going to quickly blitz back through the slides, show you what we've done, and then you can, at least if there's anything you were desperate to hear about, and I'm sure there's loads, then at least you know that it's happened and you can ask about it. So let me quickly go back through the slides, sorry. Oh, and if you've just arrived, can you let me know whether you're new to GCSE computer science, whether you're new to Edexcel, or whether you've been doing both for a while? Okay, so welcome to Pearson, obviously. So I just went through the content, the 6 main topics. So topic 1 being the problem solving, topic 2 being the programming. They make up the majority of paper 2, excuse me. Then topics 3, 4, 5, and 6 are the theory topics, which predominantly topic 1, which is the principles of computer science. Talked a little bit how it's such a diverse subject, really, that there's some maths in there with the earlier stuff and there's some problem solving, and then a lot of the questions that go around topic 6 are almost like humanities style questions and require that level of skill from our students as well, which what makes it quite a challenging subject at times, but also a really great one. I mentioned the fact that as teachers for computer science, there's something new to learn every year, and there's something new happening every day. It's almost as if I designed it, that having this issue about AWS is a great learning opportunity. It's a great thing to talk to students about, to talk about the importance of robust infrastructure, the importance of these apps in our everyday life. There are people who currently can't make, they're trying to pay for stuff they can't. But yeah, so those were the 6 main topics. Yes, the whole thing has been recorded, Adam. It's a fair point. Okay, so it will be available afterwards. But just to kind of bring you up to speed for anything that we're going to do in the next little while. So we then talked about the assessment objectives, how there are 3 levels, which is basically, as you said, demonstrate, apply, analyze. So I gave VPN as an example. So an AO1 question might be define VPN. A AO2 question might be explain how a VPN works, or what is an encrypted tunnel, or how does a VPN help with people hiding their the location of their IP address. And then AO3 might be discuss how VPNs have affected people's work-life balance since COVID, that kind of thing. And again, across the computer science, that's the balances. And then for the 2 papers, paper 1 focuses more on AO1 and AO2 with maybe an odd longer answer question towards the end on paper 3, and sorry, towards the end on AO3, so topic 6 probably, and then paper 2, application of computational thinking. The paper 2, there'll be some questions which require shorter answer stuff, but a lot of the stuff will be around analysis and the tasks with the coding language of choice. And then just talked about the fact that it's 100% external assessment, fully linear. So they do both papers at the end of the 2-year course. Each paper has a 50% weighting. The written exam and the practical exam being those two. Again, just a breakdown of the paper. So paper 1, 2 hours, all sit at the same time, 80 marks, traditional written, write a paper response, obviously unless they have access arrangements, must answer all questions, and there's a range of question types. And then for question 2, 3 hours, because coding, it tends to take a little bit longer. There's a 3-day window to allow exam centres to make sure they have the facilities to run it, because students require access to computers and that kind of thing. Again, questions are mandatory, multiple choice, short, open response. So lots of different types of questions, but the main one being there's those task-based questions as well, which tend to be around the data files that are provided as part of the exam. Do we somehow, I think, do we skip this one last time? But anyway, so again, for paper 2, choice of 3 languages. And again, there's a list of the things that the students must have. So a workstation, the folder that your exams officer will get, the pseudocode reference sheet, which helps them to answer the questions, obviously. But they can't have access to the internet. Okay. I mean, for example, we use Thonny as our IDE for Python because it standalone sits on the computer, no internet access required. Okay, so what we then got onto was these topics. So there were 3 activities: activity 1, activity 2, and activity 1, which is I'm going to call them the originals, which is the one the originals are currently doing. Those 3 activities are on the Getting Ready to Teach International GCSE Computer Science sheet, which is in the delegate pack. The answers are on there as well. Okay, so it is now 10:30. I don't know how I've just done there for time. But that's a blitz through everything that's been done so far, just so at least you know, at least you have some context. And I see more people arriving as I speak. Okay. So again, if you have just arrived, welcome. Congratulations on surviving the AWS outage, the Zoom outage powered by the AWS outage. Again, if you've got school on Monday or this week, it's a beautiful learning example, a beautiful topic of discussion for your next computer science lesson. I've just done a blitz review. I hope numbers going up all the time. Just done a blitz review of the content. But what we'll do now is, if you've just arrived and you had a burning question that you're worrying has already been asked, put it in the chat. If you just arrived and you haven't got the delegate pack, which has got the specification and the Word document in, let me know and I'll put it in the chat. Otherwise, because we're already halfway through this 3-hour session, I'm going to get going with the next part. The more feedback and chat I get off you, the better. If you've just arrived and you haven't introduced yourself, put your name in the chat, please. Okay, Pete, I'm gonna. So, Peter, it is. The delegate pack, Peter, should be there. VS Code is. Well, let's go. Let me back a second. No, Python, C# or Java. So you'll notice if you go onto the Edexcel website and look at the past papers, there's mark scheme A, B, there's mark schemes 2A, 2B, 2C through for each of the language. I'm getting the can't access the resources message. Okay. I wonder if that's now being hit. Right, I'm going to try and access it myself. No, I'm not going to do that in case I risk losing Zoom. I'm going to go back to Zoom, I'm afraid. There we go. I knew I shouldn't have done that. Also, no, it's just those three, Adam, I think. Can somebody just confirm that they can still see my screen, please? I made the mistake of deciding trying to go and find those resources, and I think it's probably messed my screen up. I can hear somebody talking as well. All right, let me just see if I can fix my screen. There's a chat. I thought so. Okay, yeah. Let me quickly try and fix that. 1 second, sorry. That should be full. That should be full screen again now, I think. Okay, Kirat, can I park? I'm going to park the one about resources because there'll be a degree of answering that question towards the end. Okay, I'm going to try and get to the end and then we'll talk about resources. Okay. Um, I said sorry. Visual Studio, as in the compiler. Okay, apologies. In my head, I had Visual Basic. So you mean as in as a compiler choice rather than a language choice? It's I'll double check with your exams officer and I'll confirm with Pearson. But it's basically it's as long as you have an IDE with the compiler for the language of your choice that doesn't require internet access, you should be okay. I hope that helps. Okay, so identify the paper for those of you who would diligently and have been extremely patient whilst other people have arrived. We had that one is paper one. So an array of two strings is paper one because it talks about 2D arrays. And it talks about a linear search, which is one of the searching algorithms they need to know. And it's spec point 1.1.7. Compiler versus an interpreter is also paper one. It's spec point 4.5.2, which is almost what we've just been talking about, Adam. Why programs use constant in their code would pop into paper two. And I'm now in my head to, yeah. So first it would paper one. 2.3.4 would be, I'm going to chill on, is it in my head? Maybe that person would be paper two as well. Anyway, why programmers use constants in their code would be paper two. The names of the 4-layer TCPI model from lowest to highest would be paper one, principles of computer science. That's always one to be careful about. We'll have all taught different names for those layers at different points. I always remember it as ATIL, so application, transport, internet, and link layer. But for Pearson, it's application, transport, network, and data link layer. So just be careful on that one. The for loop is very clearly paper 2. ASCII, because it's data representation, is and the for loop is spec point 1.1.2. The ASCII table is probably paper 1, and it's spec point 3.2.1. DNA computing very much paper 1, topic 6, and it's 6.1.4. And then the subprogram, nice and comfortably paper 2 and 2.6.2. Okay. So for those of you, again, it's all there if you need it. Was it Peter? You're asking me about the resources. I'll try again to get them to you. But if I'll see what I can do. If anybody's feeling particularly conscientious and has got the getting ready to teach international GCSE computer science as a Word document, and they can attach. I think you can all attach files onto the chat. If anybody has got that Word document and they're in a position to add it to the chat as a file, I'd be very grateful, and I think it would probably help with a couple of people on here as well. So yeah, so what's it gone? Yeah, so Pete, we'll try and get it to you way instead, if anybody can help. Okay, next thing. So planning to teach the course. This is, and I don't know, I may be talking to heads of departments, I may be talking to what often happens, which is standalone computer science teachers. You may be the only computer science teacher in your school, but I'm a big believer in being very deliberate in knowing what we're doing and when. Okay, so Pearson suggests between 120 and 140 guided learning hours. That may be something you have to discuss with your school to make sure you're getting enough hours. I would suggest creating a 2-year timeline for the delivery of materials. Again, how you do it is kind of up to you. You just need to make sure that you're covering all of the topics and subtopics. I think we can probably all. I've got at least a couple of times where I've spoken to colleagues from other subjects in the March, and they've suddenly realised that they've missed out an entire topic, which is interesting. I would highly recommend delivering programming throughout the entire course length. I'm lucky I have my GCSE groups for 4 lessons a week. And I very deliberately do 2 lessons of theory and 2 lessons of programming. I think they just have to, with programming especially, they just have to do lots of it and do lots of it early and just build that knowledge and that proficiency. Okay, you've got it. Okay, fine. Yeah, again, there's all kinds of analogies for coding, but I kind of think of it like learning a foreign language or an instrument. You've got to learn the vocabulary, and then you've got to learn how to put that vocabulary into sentences. Again, consider splitting the lessons between paper 1 and paper 2 content, which I talked about before. Maybe half for coding and problem solving and half for theory. Yes, as they will be assessed, so give them a chance to write and also live code. So I'm on half term now, but when I go back after half term, the first thing that my GCSE students have got is a live coding assessment, where I will literally put the barriers between their desktops and they'll have to code. And I would always try and aim to have the content covered, I was going to say as early as possible. My thought process is always February of year 11, I've got everything covered. It's not always the case that I hit that marker, but that's always what I have in mind. This is just how I plan. There are also some there's some planning stuff available on the Pearson website as well. I like Gantt charts, so I'm a bit of a nerd like this. But this is my planning for this year. This is actually for the GCSE rather than the IGCSE, so the content is slightly different. But that's my week by week planning of the content, just so I know I'm covering it, and I turn each box black as I've done it. Okay. There's again, there's a nice sort of 2-year planning guide on the Pearson website as well. Okay. But as I said, there is stuff on the Pearson website as well. Again, I think this is one of the really good reasons for being with Pearson, that there's some really good stuff on there. So the schemes of work, there's some lesson slides, student activities, solutions. There's lots of stuff on there that if you've never taught this specification before, it'll get you going. Okay, I think it's a really good way of getting you going. And again, Kira, you asked about resources. So that's some of the resources you can look at, and we'll talk about other ones a little later on in the session. So again, some of you will have been very experienced in this. Some of you will be looking for guidance for the first time, but getting the students ready for the exam or exams, there's some suggestions on it, which again, most of you will be really, really aware of. But you are very much, you're the experienced expert teachers. You'll know what suits your teaching. I know one of the buzzwords at the moment is adaptive teaching. You know what suits your students. You know when it suits them, how it suits them. You also know what resources you have available to. We are in this world now of AI content generation as teachers, and there's no getting away from it. Is that a good thing? Is that a bad thing? I suppose it depends who you speak to. But creating a lot of these stuff has become a lot easier. I mean, I know, for example, my students really I use Quizlet to make flashcards. They really like that. But there's tons and tons of stuff out there. Okay. Yeah, just I mean that's for anything and everything. And I think don't underestimate the importance of them learning the key terms of programming. So being able to define what a variable is, being able to define what a procedure is, the difference between a procedure and a function, what a parameter is, what return means. That's all important as well. And then for programming specifically, I could have just I could have just left this and said write as much code as possible. The more code they write, the better they'll be at it. I think it's with other factors, it's as simple as that. I think the teaching of coding is one of the hardest things to teach. Across I'm biased to say this, but it takes a lot of skill to teach coding. Okay, and how you teach it and how you deliver it and how independent you want them to be and how much you want to provide in the first place. But yeah, anything where they're error finding or whether what's called the Parsons problem, which was one of the exam questions, whether they're just rearranging lines of code. There's lots and lots of ways of doing it. And as I mentioned previously, before some of you got to join, there is a ton of resources out there for teaching coding. Computer science teachers are great. They're very keen to share what they know, and they're also very good at putting together the platforms that then allow you to access that. So, but that would boil down to write as much code as possible. Just get them writing code. Get them writing code every week as often as possible. I had a chap who he was my first head of department, and he was very much of the mantra of they should be comfortable with struggling. Code is fixing stuff half the time. So are you giving them the opportunity to be comfortable with struggling with code and getting the chance to fix it? And again, things that you might want to give them the opportunity to do. So finding errors and debugging, prim, so they can they predict what's going to happen, run, investigate, modify, and then make it at the end. Paired programming. I think I personally think a good programming classroom is a noisy one because they're having to discuss stuff. They'll write some code, they'll get code blindness, and so look at somebody else's code and then they can fix each other's. Rubber duck testing, which you may be familiar with, which is explaining your code to an inanimate object. Faded work examples, so you provide them with a lot of scaffolding and gradually take it away. Getting them to discuss stuff. I I've always tried to implement like a computer science society where the older students help with the GCSE, for example. The Parsons problem where you're arranging stuff and being able to read a brief and write the code to meet the needs of the brief. Anybody got any questions about that before we move on to the next thing? Again, we'll make sure all this is available, the recording's available, but exam tips that you want to pass on to students. So for both papers, attempt every question. Partial marks are awarded. There's no negative marking. I've worked as an examiner, and we will work very hard to find the stuff that shows knowledge. The chief examiner will say, look, try and find the stuff that shows that at least they know what they're talking about. Write legibly, speak legibly as well. I've missed one, sorry. Make sure you've got the time, which I'm very conscious of at the moment. Time to make sure you answer every question. You're allowed to write in capital letters. Again, as an examiner, it is such a relief when you look at a paper and it's legible, and it's such, when the writing is poor, we'll still try and read it, but it makes it more difficult, obviously. Bullet points I would encourage. Make sure they use their subject-specific terminology, they use all the correct terms, which is why knowing all those core languages is important. Read the question, say about that all the time. They don't have to fill the space, the number of students who feel they need to put a word on every line. And then for the practical paper, so the paper 2, make sure that you've had a practice of it, either as a department or as a whatever, but make sure that your students know how to use the IDE, whether it's Thonny or VS, we say VS Code, I think it said. Encourage them to save the work on a regular basis, like every 10 minutes. I've had one occasion over the past few years where a student kind of got into the exam, forgot to save everything, and the computer crashed with 10 minutes to go. And the original files will go on the computer and just say, look, if for some reason you do lose them, we can get them back on there. But again, I would have a very deliberate talk with your exams officer and with your IT team on how you as a department are going to manage that practical paper. Does anybody have any questions about that before we move on? There's no questions in the chat. I can have 3, 2, 1. Okay, we'll move on. So I'm not going to spend much time on this. It is all available on the specification, but it is worth making students aware that the command taxonomy, i.e. the words that are used in the questions, are a really good indicator of how they should answer that question. And it's about 3.5 pages. I only remember this because I spent quite a lot of time copying and pasting it. But they should be finding this word. Look for the command word, then look for how many marks the question is worth, and that will give them a real indicator as to how to answer it. I would be very deliberate in talking about these command words, so how they're linked to the AO1, AO2, and AO3. But I'm not going to spend ages on this. They are available, and we're short for time. Okay, but here you go. So here's an example of use of command taxonomy. So explain why a person attempting to gain unauthorized access to a network can sometimes benefit the owner of the network. 2 marks. Okay, so they're going to get a mark for each of them. So again, let's go to the examples. So why explain why a person attempted to gain authorized access. Okay, so it exposes security vulnerabilities. Well, that would be identify why a person attempting to gain authorized access. So that'd only be 1 mark. For the explain, for the 2 marks, it's then saying it's by somebody who's paid reward to do it. It's ethical hacker, white hat hacker, however they want to do it. Okay, but explain is almost certainly going to be a 2 marker. So first point with a backup point explaining, giving a little bit more detail. Okay. Again, this is a paper 2 example. So amend the code to correct 3 program errors. So they know that they're fixing stuff here. Okay. And again, this is one of those that it'll be in the codes folder as Q01C, and they save it as Q01 finished again, which shows that you should be, you should spend time deliberately teaching them how to manage their files in the exam. But again, this one, so what's going to be fixed? Is that the fixed one? So in fact, this is the fixed one because total's now been initialized and there's an equal statement in the if, and odd is now indented. So that's the fixed version there. Okay. I'm aware I'm going quickly, but I'm hoping everybody's keeping up. Anybody got any questions about the command word taxonomy before we go on to mark schemes? Okay, we'll go to mark schemes. So mark schemes are there for predominantly for examiners. They are there to make sure the examiners can mark those exams accurately, fairly, equitably, and consistently. Obviously, we then make them available to. They are then made available to everybody really, because they're an important part of you getting your students ready for the exam. So they are the answers to the questions. They provide a number of options that students might give. I have been an examiner and a team leader for examiners in the past, and we sit in and we discuss in some detail how to answer these questions. Discuss all the possible options that students can give, that candidates can give, all the potential indicative content that we could give. What we're trying to do is eliminate all and any ambiguity. We're trying to make it so that when the examiner is marking it, there's no wiggle room. It's a 2-day, 10-hour a day process of trying to ensure that the mark scheme doesn't leave any wiggle room. And it's a really interesting process to go through. But that last one, so examiners are encouraged to use the mark scheme positively and look to reward marks for what is there rather than penalise for what isn't. We're trying to make sure that if there's content worthy of a mark, they get the mark for it. Okay. So different types of mark schemes. These are the points-based mark schemes, often bullet-pointed mark schemes. They're the most straightforward ones to answer, really. And again, what the examination team will do really, really well is give you as many possibilities as possible. So they set out precisely how each mark is rewarded, how many points can be rewarded for. Additional guidance is really, really important, especially, I was going to say especially for paper 2, but actually for both. So this one is obviously a question about what is a wide area network, or it's obviously talked about what's the difference between a local area network and a wide area network. So again, they're going to get marks here for either talking about the different definitions, different bandwidths, the actual makeup of them, latency levels. There's all those things in there. But then you need to be really careful and read the guidance to say, okay, don't provide. So if they've said, for example, students said, well, wide area networks cover a large area, whereas local area networks cover a short area, that's 1 mark because it's talked about area. So it says there, look, do not award 2 marks for the same point. Okay. They're looking at differences between them rather than descriptions of them, if that makes sense. So you could say there's a bandwidth difference in the geographical difference, and this is how they work. Okay. Again, do not accept LANs can be wireless. That's again a little bit off topic. And again, very careful about general points such as WANs can be slower. Doesn't really mean anything. Again, the number of you'll see an answer. The difference between LANs and WANs, and somebody up here, well, LANs are better. That doesn't mean anything. Okay. But on the whole, the points-based ones are easier to mark and easier for you as a teacher to mark. I would suggest as well. So again, here's a points-based example. So this is nice and easy. Okay, so converting, so using 2's complement to get minus 38. So generating 38, is that right? 32, yeah, fine. Flipping the bit, adding 1, getting the result. Okay, so there's 3 marks. 1 mark for getting 38, 1 mark for flipping the bits, 1 mark for adding the 1 to get the result. There's other alternative solutions given, but the correct answer only gains 3 marks. If they've put in 1101, 1010, there's a good chance that they did the calculation somewhere, but they must have known how to do it, or else they wouldn't have the right answer. Okay. So I think that would be a maths teacher's worst nightmare, in that they can get the 3 marks without showing any working. But if they've got the answer, they've got the answer. Hope everyone's okay. Hope they're keeping up. Again, another point-based one for paper 2. And again, this would tend to be one of the earlier questions, which is basically, this is what they need to do. So this screenshot has given the pseudocode, and they just have to write the code underneath it. Okay. And it'll be, have they done this? Have they done this? Have they done this? But here you go. So I'm hoping that my toolbar isn't across it at the top. So again, they get a mark for attempting to input the input and print country, printing the string. Again, if you can see these things, they can have a mark for it. Yeah. Again, this tends to be the earlier questions in paper 2. Anybody got any questions about the points-based questions and mark scheme? Because I'm now very conscious there's an hour to go. I know somebody's got their microphone on, but we'll accept, as long as you're not making too much noise, we can cope. Okay. Levels-based mark scheme it's important because it often allows for greater depth of knowledge demonstration in papers 1 and paper 2. So what we're looking for often is the best approach. The command words will tend to be discuss, evaluate, analyze, write, that kind of thing. And the indicative content is just that, actually. It's the kind of thing you're expecting to see. But with this one, the examiners are having to use their, I wouldn't say discretion, but they just, there's a little bit more that they can look for that perhaps isn't explicitly in the mark scheme. But for paper 1, it'll be depth of knowledge. So again, if it's discuss the role of VPNs in modern workplace, it would be talking about VPNs, and then it would be looking for 2 or 3 ways in which VPNs have impacted the workplace. It might be work-life balance. It might be being able to remotely work. It might be the creation of virtual local area networks using a VPN, that kind of thing. And then for paper 2, rather than simply coding, it will be, have they decomposed the problem? Are they using logic well? Good use of data types, good use of data structures. Have they used the correct loop? Have they gone count controlled or condition controlled? Is their code clear and readable? They'll get credit for that. Are there indentations in the right place? Have they put comments on there? So beyond just simply writing code, have they written code well? It's very quiet out there. I'm assuming everybody's okay with this. So here you go. So this is very much an essay style question. So a team of researchers are studying urban wildlife, foxes, etc., collecting data during the day and night. Sometimes they work in an office. Here's what we use: identify the secondary storage medium most suitable for the team and justify why it best meets their needs. Okay. So 6 marks. Okay. So there'll be a mark for identifying a secondary storage medium, and then but the main marks are here for justifying why it best meets their needs. Okay, so they need to be able to talk about the characteristics and advantages and disadvantages. Okay, so they can put that cloud storage is the most suitable. Okay, the reason being is that it says sometimes they work in an office, collecting. They use a range of laptops, tablets, and smartphones. So it's tried to lead them towards the fact that this is a very mobile, fluid, organization. So they'll get a mark for saying cloud, or okay, and then you've then got indicative content. So have they talked about accessibility and what makes it accessible and why that's a good thing? Have they talked about what collaboration is in regards to cloud storage, file compatibility in regards to cloud storage? That's the kind of indicative content. And then as somebody marking it, what you'll then do is I tend to start at the top and work downwards. And I'm like, okay, well, could I describe their work using the descriptors for level 3? If I can, then I need to decide whether it's level 5 or 6. Okay, so for level 5 or 6 here, they need really to have probably talked about at least 2 of those areas and gone into a nice amount of detail about those areas. So explaining why it's relevant, explaining the impact, explaining the advantages and disadvantages. But as it says, the discussion is well developed, sustained line of reasoning. Okay, so again, the top bit is what they can talk about. The levels are how they can talk about it. So I'll talk quickly about the mark schemes. So they are developed at the same time as the original papers. When the chief examiner is writing the papers, they'll be writing the mark scheme. Again, I can't. The level of scrutiny that the mark schemes go through is significant. Okay, they may be revised after the students sit papers. Do you get that student who just throws something into the discussion that was never discussed before? The mark schemes are then standardized by the senior team, and examiners go through a whole day of standardization, learning to mark it, learning to use the mark scheme to mark. Okay, and the aim is consistency. Predominantly, it's consistency. Okay, so we are now on to 55 minutes to go. I think we're going to be okay here. So if we are now on to the mark scheme work. So on the getting ready to teach international computer science, there is, I've skipped a bit, but that's okay, we can cope with that. There we go with that anyway. Okay, so we're going to do the first activity, which is marking paper 1. Okay, so I'm just going to make sure I'm in the right place here. Okay, I am. Okay, so is this going to work? Excuse me while I find my right place on both these documents. There you go, found it. Okay, so we're going to go to the on your document. It's the sections that starts paper 1, principles of computer science, and you should be able to see this question on it. So if we can all find that, please. So that's the question. Okay, and it has got the mark scheme that goes with it, and then it's got a couple of scripts underneath, script 1 and script 2. So how this is going to work, okay, so here we go. So you should be able to see that. You should be able to see the question on your Word document, and then the 2 responses as well. Okay, and the aim is to mark both scripts. Basically, what they give each of those out of 2. Because somebody just confirm, or if you're still here, Can you confirm that you have access to the Word document and can see that question, please? On my Word document, it's on page 24. It should be on page 24, I think. Yeah, it's showing on page 24. Perfect. Thank you, Peter. Okay. So here's what we'll do actually. Rather than keep jumping backwards and forwards, so for paper one, there are 1, 2, 3, 4, 5, what about 6? There are 6 questions. So there are 6 questions for paper one. Okay. So here you go. There's a 1, 2, 3. Okay. Questions. So that we've got time to have a look at paper 2 as well, I'm going to say 25 minutes. We're going to spend, you're going to send, no, I'm going to have to change that. 20 minutes. Okay. So the time is now for me 9 minutes past the hour. At 29 minutes past the hour, we're going to come back together and I'm going to go through how many marks these responses were awarded. Okay. 20 minutes, which is it's quick, as we've got no choice. Okay. If you haven't got access to the Word document with the screenshots of the question, the mark scheme, and the responses on, let me know. Other than that, get going. 20 minutes. Let's see if you can, even if you're just doing one of the responses per question for now. Anybody got any questions about that? Okay, we're 19 minutes now. So okay, yeah, okay, quick as you can. But we'll aim for going through the answers at going through the answers at 30 minutes past the hour. Okay, I am here, but I'm going to quickly switch my audio and video off so because you don't need to hear me making a cup of tea. I hope everybody's going okay with this. If you think that my time frame of finishing at 1/2 past the hour is too generous and you think we can be done before that, let me know. We can't really go anything past that. But if you think actually you might be good to go before that, just let me know because the sooner we start, the better, really. if you feel that you are now ready to go through these responses and look at the marks they were awarded, can you just let me know in the chat? Because again, I think I apologize in advance. We're probably going to overrun a little bit today. But the repetition that the AWS outage has caused, has necessitated, is just, it's not something we couldn't have preempted that. So if you feel ready to start going through these answers, can you just let me know? I think worst case scenario is, at least if you're looking at the answers as I tell you how many marks they got, at least we've got through them. Because that may end up being what we do with the second one. Okay, Adam, you're ready. Okay, yeah. So we got two, and it's the two people who've been most vocal. So unless anybody vehemently objects, then we're going to get going with what these responses got. Nobody's going to veto our plans in 5, 4, 3, 2, 1. Okay, so first question. So this is a question of virtual memory. We have two responses, and both of these were awarded 2 marks. Okay, so both of them acknowledge that virtual memory is when either RAM is full or an alternative to RAM, and how it's done. So first one, virtual memory works like RAM. Instead of using the actual components, so it said, look, virtual memory is like RAM, but it uses SSD. Fine, so that gets the marks. When the RAM is full, fine, that's when virtual memory is used. Then the currently used applications are stored in virtual memory. Okay, I would say that there's an element of benefit of doubt with script 2, but if we look at I've not provided them. Yeah, the mark schemes on. Okay, he's scraped through on that one. Okay. Okay, so next one. This is a constructed expression, because obviously they're not allowed calculators. Okay, because they're not allowed calculators, then we have to ask them to write the expression instead. Yeah. Okay. So if we look at the responses, so this is okay. So there are marks for doing the 80 times 66 times 2, or 80 times 66 times 16 divided by 8. Okay. So script 1 got 3 marks. Got a mark for getting 2 times 80 times 66. Yeah, they've done. I think. Yeah, the metadata they've done times 40 instead of plus 40, so they can't have the mark for metadata because it's just adding rather than multiplying the whole mark thing by 40. They divided by 1024, and then they also rounded up the number of blocks. So they got a mark for 2 times 80 times 66, a mark for dividing by 1024, and a mark for rounding it up. The second one, the one below, they got, again, they kind of got there in a roundabout way, and they got the benefit of the doubt here, but they did do the 80 times 66 times 2, and they did divide by 1024. They've got the little arrow which they've kind of shown that they're doing the multiplication. So I think that's an example of the examiner going, well, actually, I'm looking for the positive there, and it looks like you multiply by 2, so we're okay. Okay, but they've not done the rounding, they've not done the metadata. Okay, next one. Okay, so this is about protocols. Email protocol and justification. So script 1 has got IMAP. They're then inexplicably called the IMOP in the justification, but we've got IMAP in there. And they've got 3 marks for that. Okay. So question was out of 3. So they've got all 3 marks. So yes, they've identified IMAP. Then they've provided some justification. So the first there's a first mark for what's underlined red. So what it only downloads the basically it talks about IMAP getting the message from the server and bringing it back, and doesn't want one. Yeah, it takes lots of storage on all of them. So he's recognized that IMAP is syncing with the server and not having to store stuff on her tablet. Fine. Okay. And then this response got, I think, 2 marks, if memory serves me right. Yeah. So they get a mark for saying it's IMAP, and a mark for saying that it gets sent to both smartphone and tablet computer. So she's acknowledging that the messages go to both. And the rest of the answer doesn't really make any sense. Wants them to be linked. IMAP is better as it does it better. So that last 2 sentences is it's better without anything other than it's better. Okay, you could have deleted those last 2 sentences and it made absolutely no difference. Everybody okay with that so far? I hope so. We'll go on to the next one because again we're tight for time. So 6 marks. Discuss the statement considering characteristics, uses, and ethical issues in AI. I mean, that's a hell of a broad question, especially nowadays. So, as increasing impact on our lives, discuss the fact that it says an increasing impact means they go positive and negative. They're quite lengthy responses, these ones, obviously. But the mark scheme gives some indications as to what they can put. So the mark scheme talks about, I'm just going to find my copy of the mark scheme as well. So it's got some characteristics that they can go with. So there's some indicative content, and then there's a level. So this one, script 1, once you, I was going to say once you decipher the writing, but actually this is pretty good compared to most. For that one, 6 marks. Okay. There was some nice information in there. It was pretty good on the whole. So they fully meet the descriptors for level 3. They've included characteristics of AI, discussed some ethical use. There's some it's level 3 for the descriptions, but also there's a nice amount of knowledge in there as well. It's when a program is capable of making human-like decisions. Different levels of artificial intelligence. It's possible that AI will replace. Okay, there's a good level of knowledge. They clearly know what they're talking about on that one. And on the second one, which is this one, this is 4 marks. Okay, it's a level 2 response. Doesn't really go into a huge amount of detail. The discussion is pretty much on one thing and one thing only. Okay, but they clearly know. They clearly have some knowledge. Okay, so although it didn't get level 3, it was 4 marks for level 2. Okay. Okay. We've gone too far here. No, that's fine. Okay. Okay, so the time is now, ladies and gents, 11:35. So now we go on to the marking of paper 2. You never know, we might get done. We might get this done by the top of the hour as we go anyway. So the questions for paper 2 begin, and I'm sure somebody will confirm this, on page 38. So again, you have the question. You have some data if it's gone with it. So on that first one, for example, there's some things they need to fix. And then you have the mark scheme underneath. So things that are being looked for. Okay. So you've got the paper 2. I hope I've done this right. Yeah. And then you've got the scripts. Okay, so you've got the 2. I think I got the 1 script for that one, actually. If I apologize. There's two scripts for that as well, I think. I think that might be a slight glitch on there. Yeah, no, there's one. There is one. Okay, so there's the response. Okay, so you have the. So we're now on to paper 2. You have the question. You have the provided script, and you have the response that the student has given. So this is amending the code. I apologize that it's Python only. I went with the one that is historically the most popular. Yeah, see how we go. So again, for this one, there is, I'm going to quickly check. There's 1, 2, 3, 4, 5, 6. Get as many of them done as you can. That the last question is a 20 mark, is one of the 20 markers. Okay. It's a shame because that's one that almost will take the most, be of the most benefit. But again, the time now, folks, is 37 minutes past the hour. If I said 18 minutes to take us to 55 minutes past the hour, I think we're going to have to work with that, I'm afraid. Okay. I'm going to assume everybody can see the content for the next paper 2 stuff. Again, now we've run out of time, I'll have a chat with Nash at Pearson, and we'll make available to you the paperwork with the marks allocated to the responses and why, if we don't get time to go through it now. Okay, anybody got any objections to cracking on for the next 18 minutes with the paper 2 marking? Everybody okay with that? Nobody's objecting, so I'm assuming we're good to go. Oh, I'm just seeing a message. So, thank you. Great. Folks, just let me know in the chat as you finish, and obviously because the soon we can get, because there's technically 16 minutes left of this whole thing. So as you think you're ready to start to go through the answers, let me know. But I suspect what's going to have to happen is we'll make sure you get provided with um, details of how those responses were marked and the answers they were given and why, so that if we don't get to go through it now, you at least have that for reference later on. I'm going to answer Peter, just for those of you who are busy working away on the coding stuff. So good websites, resources and websites for pupils to practice the programming skills they need in paper two. So I'm going to speak. As far I'm going to try and answer that I'm aware. Pearson don't. I don't think there's any recommended platforms. So I'm going to take off my Pearson training delivery hat and just put on my computer science teacher hat for a second, and tell you what I'm using. So I've used different ones in the past. There are all kinds of stuff available. I found Code HS is okay. At the minute, I'm using Time to Code just to get my students up to speed. That's not that's not a Pearson recommendation by any stretch of the imagination. Just to put that caveat in there. I'm just telling you that's what I'm currently using with my year tens at my school. Time to Code. It's a pretty nice one. It uses Trinket as its online IDE. It's got a nice kind of development of knowledge. So that's the one I'm using at the moment, Peter. But please don't take that as a Pearson recommendation. I think maybe you weren't on the call, but oh, no, I think it was. Yeah, there's so many things out there. It's it's tempting almost to just jump from one to the next. Um, I still don't think there's any substitute for you as a teacher giving live coding demonstrations. Certainly when at the very if I'm starting coding in Key Stage 3 in Python, I'll have there'll be some periods of time where I am coding live coding on the board and they're having to type. It's like again um, getting them to repeat vocabulary in French. So that's always a good starting point. Yeah, but I'm trying to think what else I've used in the past. I've used Replit, but then that has to be paid for. Um, I've used Code HS. If you go onto the Edexcel website for computer science for the GCSE computer science rather than the GCSE, there's actually if you have a gateway login, you should be able to access their resources that go through a lot of the stuff of Python as well. There's a series of sort of 10 modules of work regarding programming, which is actually a really good one. So if you, yeah, it's worth going on to the Edexcel GCSE computer science website, and because there's some really good resources on there for programming as well. obviously you got loop, especially for loop. When you say nested code, you mean nested ifs. So nested selection statements, I assume you mean. Yeah. So my first port of call, try the Edexcel GCSE computer science website. The specification's been going since 2020, I think. So obviously it'll have the 2020 brackets. I think it's one CP. Anyway, it's the most recent GCSE in computer science. If you have the right platform access, there are actually blocks of coding lessons you can download for the students to have a go. It is. I mean, I'm going to keep talking. We've got guys. Maybe in a couple of minutes we'll get going on these paper two answers, and then we'll probably only be able to spend 5 minutes on it, and then I'll have to wrap up. So, it's an interesting one. But I don't know your situation is, Peter. I know that there is. Well, there is an absolute dearth of specialist computer science teachers out there. Targets are being left, right, and centre. I think, with the exception of English and maths, we're about the most advertised job vacancies on tests, which, considering that we're technically an option subject, a non-core subject from GCSE onwards, is impressive. So I don't know whether you're in a situation where they said, okay, Peter, whether you've been in this for years or whether they said, Peter, you go do computer science. I'm sure you'll be absolutely fine. But I would recommend that those are the two options. I would also recommend, there's loads of really good computer science teacher forums out there. You can get onto them, and if you're ever sort of looking for information, you can always reach out to people. I don't know whether am I allowed to. Again, I'm happy to be reached out to. Don't know if Nash is listening in, but Nash, I don't know whether I'm allowed to share my email address on here if people want to reach out for questions about just content stuff later on. But again, as computer science teachers, I think we're all very aware that there's not many of us and that we need to help each other. And again, coming back to an earlier question, we need to be champions of our subject. And if that means supporting each other to make sure that computer science provision is as strong everywhere as possible, then so be it. Right, ladies and gents, there's 7 minutes to go, so I'm going to call it, and I'm going to start to go through some of the marks that these responses got. I don't think we're going to have a chance to go through that 20 markers, so we'll provide the information for that. But let's quickly go through these. So this is just amending the code. There are 3 errors. They've just got to find it. So it tells them what to do. Program should print out the counter with 7 added to it. So the 3 errors in the code. If I can get this to work, I think let's try that. Oh, let's go back a second. So the 3 errors in the this response got 1 out of 3. Constant value was not being defined, so that would be an error message on line 8. They did add the semicolon on the end of the while loop, but they haven't changed the line 8. They haven't changed the capital C count to lower C, so that'll be an error as well. So that one gets a 1 out of 3. So with this one, it is amending the code to complete if statement. So basically, can they do an if with the correct conditions? So shop income is more than 5,000, or the sales assistant has shown at least 10 pairs of shoes. The bonus is 10. The shop income is 20,000 or more, and the sales assistant has sold at least 5 pairs of shoes. So this response got 2 marks out of 4. So I think what did you say? Sold at least 10 pairs. So they've said it should be shop income is greater than 5,000, or assistant sales is greater than or equal to 10. And I think it's the same on line 14 as well. So they've put equal to 5, and it should be greater than or equal to 5. So they've got 2 out of the 4 marks because only one of the 2 relational operators was correct. Okay, so they only had to amend the code. They only had to get the Boolean operators incorrectly, and they got one of the 2 correct. Okay, so they got the ones for the 5,000, 2,000 correct. They got the ones for the 10 and 5 wrong. Okay. So this is a 10 marker. There we go. Again, I've got about 3 screens open here. There we go. I've gone too far. Okay. This is PO2. Excuse me a second. Yeah, so this is writes and programs. So the pseudocode contains the logic. Write the program to implement the logic in the pseudocode. So basically, under each comment, they're going to have to write some code. This one was awarded 4 out of 10. Okay, so they got a mark for line 6, setting counter to 1, and line 8 setting guess to 0. So those initializing those 2 values, they got a mark for that. They got they didn't get the mark on line 7 because random dot int is not a valid call. I think it should be random dot rand int, shouldn't it, instead of just int. So that wouldn't work. So they wouldn't get bullet 2. For bullet 3, line 12 does not use a variable guess. Okay, so they should have used guess instead of number. Line 4 should, sorry, line 16 should be not equal to. So they've used the pseudocode. That's a frustrating one for them. Is I can see they've used not equals because they've used the pseudocode version, but actually they should have used the Python, which is the exclamation mark and the equals. Bullet 5 is on line 15, except they've adjusted it slightly. So the increment counter. Oh, somebody's got a question. 1 second. So on line 17, the incremented counter properly. Yeah, Rania. Because of the way time was run. Yeah, I'll get them out to you. I'll speak to Ash afterwards, and we'll work out a way of getting them out to you. But yeah, so I'm going to have to finish on this one. So 16 to 19 does, sorry, 18 to 21 uses selection well. They get a mark for that. 22 should be inside the loop, so they don't get the mark for it. 26 does display guesses correctly. And there are syntax errors, and it doesn't function properly, so they lose the last 2 bullet points. So there you go. Right, but Rani, I agree. So we've run out of time to do that. Rani, I'll speak to Pearson afterwards and make sure that what I'll do is I'll put the guidance I've got to me into a doc, and I'll try and get the PowerPoints out to you as well. But it's frustrating that we ran out of time. And the AWS outage has not helped either. So there's these ones to still have a look at. But to wrap up, folks, there you can see example of band marking on ones. But I'll speak to Nash and Pearson, and we'll work out a way of getting all this out to you. Okay, so from here on in, guys, if you do need any extra support with the qualification, okay, first place to go is the website. So there's lots of resources and materials on there. There's also Tim Brady's contact details. Tim has been the subject advisor of computer science and ICT for a long time. Really knows what he's talking about. Well worth reaching out to Tim if you've got any problems. There's a load of teaching resources, teaching and learning materials on the website, the specification, past papers, any training content that's been done in the past is on there as well. I would recommend getting in Results Plus. So after the exams, he helps you to drill down into where your learners went well and badly, and then you can adjust your teaching later on and delivery later on if you need to. But that's really worth having a look at in the days following your exam results. And the Exam Wizard is again great. So it uses all the previous papers. You can basically build your own assessments based on the content that's from previous years. Again, access to the scripts is worth having a look at. It's including your qualification fees and allows you to have a look at your candidate scripts, what was given for it, and see if you can. I've used that in the past to see if I can find some common errors or mistakes that all of my students has made, and whether that was something we were doing right or wrong as a department. And then the last one is the textbook, the student book, which is the paid for resource, both as a hard copy and digitally as well, I think. Again, I use Pearson's Active Hub, and I use it all digitally, so that's really nice and handy. Again, Tim, I've already mentioned. His details are on the website. He's there to be reached out to if you need stuff. There's the Pearson Professional Development Academy, which again you can access, I think, via the website. But again, if we're going to get this PowerPoint out to you, you should be able to get it on there as well. I'll leave the QR code on the screen for about 10 seconds, but it's worth getting the newsletters through. It's really good to hear about what's going on. You may well be on that already because you're here, so you may have heard about this training through those newsletters. I'm about to change slides. If you want to scan the QR code, you've got about 3 seconds. Apart from that, we're done. A little bit over, for which I apologize. I think with the AWS outage causing problems with Zoom, I think we've just about got where we needed to be. I appreciate there may be some frustration at not having covered all of the stuff for the paper 2 questions, but I'll liaise with Pearson and see what we need to do to get that stuff out to you so that you can use it as reference afterwards.